Build a fast text search index in pure Python. By the end, you will have a working inverted index, a simple ranked search that uses term weights, and a tiny top K retriever you can extend. You will see how documents map to terms, how frequency and rarity change scores, and how to prune candidates for speed. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. An inverted index matters because it optimizes lookup and recall for text search. It gives you direct access to all documents that contain a given term, which cuts search latency. The trade-off is memory and build time versus query speed. For small corpora, you get instant results. For large ones, you must consider compression and incremental updates. Intuitively, it shines when you need exact term matches and fast filtering. It struggles when you need semantic or fuzzy matches without extra indexing. Next, we will build a tiny working example and watch the results. We will build a minimal inverted index, compute simple frequencies, try a Boolean baseline, add inverse document frequency weighting, and then show a top 2 search that uses the index to cut work. This snippet builds a minimal inverted index mapping terms to document IDs. It creates a tiny documents dictionary with 3 short strings and uses a variable named in to store a set of document IDs for each token, so duplicates never inflate postings. The code lowercases and splits each document in a compact loop, adding each token to its posting set. At the end, the snippet converts each set to a sorted list and orders the terms for a stable printed view. The output shows which documents contain each word and proves the core idea. Terms point to the documents that mention them. Now we will extract document level counts and document frequencies. This snippet derives term and document frequencies for the tiny corpus and packages both signals for later scoring. The variable TF holds a counter for each document, telling how often each token appears within that document. The dictionary DF then measures how many documents contain each token by looking at the lengths of the postings in the inverted index. To make the output predictable, the snippet sorts DF by frequency and then alphabetically to break ties, and it takes the top 3 entries for a compact display. The printed tuples reveal which terms appear most widely across documents, a basic signal you will use for weighting. Next, we will try ranking by simple Boolean matches against a query. This snippet ranks documents by simple Boolean coverage rather than weight or frequency. It sets a query string and turns it into a unique set of query terms, so repeated words in the query do not overcount. Using the document level counters, it computes a score for each document equal to how many distinct query terms appear there, rewarding coverage across the query. Results are sorted by highest match count and then by document ID to keep ties reproducible. The printed list shows documents ordered by how many query terms they contain. This gives a clear baseline ranking that is cheap and easy to implement. Now we will add a rarity factor so uncommon words carry more influence. This snippet upgrades the scoring by introducing inverse document frequency as a simple rarity weight. It builds an IDF value for each term so that common words get smaller weights and rare words get larger ones, expressed as 1 divided by 1 plus the document frequency to avoid division by 0 and to keep weights bounded. For the query, the snippet sums term frequency times IDF for each document, which lets a single rare term outweigh several common ones. Sorting by the weighted totals and rounding for display shows how a rare term can reorder rankings. The printed result highlights that effect using the example word berry. Finally, we will prune the universe of documents and return the top 2 results. This snippet performs a compact top K search using the inverted index as a filter to collect candidates. It unites the postings lists for all query terms to form a candidate set, which cuts the scoring work to only documents that actually contain one of the query words. The snippet then computes weighted sums using the previously built term frequency and IDF values only for those candidates. Sorting the scores and slicing the result returns the best matches and simulates returning the top 2 hits. The printed pair shows the highest scoring document first and completes a tiny but usable baseline retrieval pipeline. Recap: an inverted index maps terms to document IDs for fast lookup. Use it when you need quick, exact term matching and scalable filtering. Caveat: it handles exact matches well, but needs extensions for semantics or fuzzy search. Next step: try TF-IDF with bigrams and tune the n-gram size to capture short phrases, while watching how index size and precision change. If practical IR tools help you, subscribe and watch the rest of the IR series.